Okay, thank you very much, everybody. So we start the first session today during the fourth day of the MERT School. We are very happy that we have together Dr. Isabela Obieta. Thank you very much for accepting our invitation to participate in the school. So your webinar will be from the side of EU. That is very important for everybody. Let me introduce the speaker to the audience. So the webinar will be about responsible electronics. That, of course, is the focus of the school. So from research to entrepreneurship, the EIC perspective. EIC is the European Innovation Council. And if I'm correct, Dr. Obieta is a manager of responsible electronics call and other relevant calls from the European Union. So a few words about the speaker. Dr. Obieta obtained a master's degree in physics, specifically in semiconductor physics from the University of Basque country in Spain, and later earned a doctoral PhD in science, specifically microelectronics materials for sensors from the University of Navarra in Spain. Then she worked in AT Bell Labs in USA in the field of modeling and simulation of electronic components. Then she moved back in Spain. She joined one of the leading manufacturers of power discrete components as an R&D engineer, and later became the manager of engineering and production of the wafer fab. That gave her a wide picture of the microelectronics industry. At that position, she started her links with the European Commission as the representative of the group in Eurimus, which is the Euroca initiative for promotion of microsystem uses. So this is a technical committee. Several years later, Dr. Obieta moved as a project manager in the field of materials and microelectronics, microtechnology for electronics, in the largest technology center in Spain, in Tecnalia, where she has initiated, managed and coordinated several new initiatives and programs around electronics. She has been also director of several business areas, leading their market technology and IP strategy. She has been managing a large portfolio of European private projects in the field of micro nanofabrication, functional surfaces, sensors, and printed electronics. So with this, I would like to thank you again, and I give you the floor for your presentation. Thank you very much.
No, thank you very much. Is it better now? Because I managed to take
Yes, now it's clean.
Okay, so I think I know what it was. Sorry for that. And thank you very much for this invitation. I'm really happy to be here and to try to explain what we are doing at the European Innovation Council to really bring research to the market. And my field, as you mentioned, is responsible electronics. So I'm a program manager for it here in the European Innovation Council. And I will try to give you a little bit of interest in this innovation journey and see if we manage to bring more people to this field, because we are very good at research, but maybe not so good at bringing it to the market. So that's our mission also here. Yeah, thank you very much for being here, for listening to what I wanted to tell you. I will try to do it a little bit interactive, but I'm not sure if with this audience it's so easy. I don't think we have a Slido or anything, but please do not hesitate to raise your hand, stop me if you want at any point. And maybe, Konstantinos, you can even tell me there's a question, because maybe I will not see it.
During previous webinars, we usually have 45 minutes for the webinar, and then we have 15 minutes at the end for questions. But if you prefer, we can read the questions.
Well, if there are questions that arise in the middle of the presentation, I also have a couple of questions that if someone wants to intervene, I'm happy to stop and they can intervene. So I would be happy to do it that way. I also planned like for 45 minutes, so we will also have time at the end of my presentation. So yeah, with that I will start. So let's see if this works now. Yes, it does. So this is what I had prepared, a little bit of theoretical issues on what's the innovation, also how the European Innovation Goal meets and intervenes into this innovation ecosystem. How do we understand innovation management? How can we bring this to this responsible electronics field? And a little bit of future outlook on this innovation in the field of responsible electronics. Really optimistic panorama, I think, we have in this field. So I'm happy to share with you those thoughts. So what's innovation? I'm pretty sure that everybody knows what innovation is. This is really basic stuff, but I really want to start with telling that innovation, there's not a single definition. There are many, but I picked up three of them, of the ones that are really normally shown on many presentations. So the first one comes from the guy that invented the post-it note. So he mentioned that the research is the transformation of money into knowledge, but innovation is the transformation of knowledge into money. So money is the important part here. So really bringing something to the market and being something valuable. There's another definition from Joseph Schumpeter. He was a relevant economist from Austria, I think he is. So he says innovation is the market introduction of a technical organization and novelty, not just its invention. So again, market introduction, this is the wording that are important. And the final one is from Mary Barra. She was the CEO of General Motors, then she went to Disney. Well, she's a very relevant US person. So the definition has to do with the customer value. So innovative is providing value to the customer. I know this is very simple, but I really wanted to make sure that we all understand that innovation has to do with doing something novel and also bringing value to the market, to the customer. So the main questions that we have to ask ourselves if we want to go for innovation is on how to bring value to the customer. So what problem do we want to solve? What need are we tackling? This is super important when we talk about innovation. I have this joke here that I usually like to show because it's very representative of things that we have myself and we've done. So our technology solution is so amazing, it can solve problems that don't even exist. So we will never bring it to the market. So this is just to remind you that bringing it to the market is important. But there are two approaches in innovation. So one is what's called pull approach. So it starts from a need that is detected. We go all the way to studying the problem, identifying solutions, and I'm not going to stop on those, but at some point we have a proof of concept, a proof of the principle. Usually it's very good that we patent, we will talk about it, and somehow we bring it to the market. We can even either bring it to the market through tech transfer, licensing kind of things, or having a startup. So this is very important. Bringing to the market is very important. The other approach is what we call the push approach. So you are coming from a material, a technology, you already have this development and you start thinking about the applications that this might have. But again, you will follow the same path. So at some point you will have a proof of principle and at some point you will need to reach the market. So at the end of the day, in both cases, we need to create something that the market wants. And this is the main message, first message about innovation. So how does the EIC goal intertwine somehow with innovation? So this is one of our visions. So backing visionary entrepreneurs. So this is our mission. And our goal is to support disruptive innovations and to also to help in the scaling up to commercialization. So we are really investing in very high risk opportunities. So this is startups on deep tech, and this is where our sweet spot is. So why did the EIC was born? Somehow it's quite new. It started in 2021 with a pilot phase into 2020. So the first problem it wanted to tackle, it was that, as I mentioned, so Europe is very strong in research performance, but not in translating into innovation. So we really lack of breakthrough, disruptive innovations that create new market. That was the starting point, and this is very relevant. We also wanted to somehow bridge these innovation funding gaps, the called valleys of death. So there was also a problem, and there was no funding for the transition from lab to enterprise, and there was no funding for scaling up of high-risk innovative startups in Europe, whereas US is super competent in this. And then we also have other problems that we're trying to address, like the fragmentation at European level of the innovation ecosystems. And also they want to include all regions, and specifically the diversity, like female talents, into this innovation ecosystem. So those are the main goals of the European Innovation Council, and this is why it was born. So for those of you that know a little bit how the European big framework of research works, this is the Horizon Europe that I'm showing here. The European Innovation Council is in the third pillar, so pillar 3, called Innovative Europe. Maybe some of you have grants coming from Marie Curie, or you're part of ITN networks. I'm not sure where Emerge is coming from. I guess it's pillar 2. Probably it's a pillar 2 project. Is it?
It's research infrastructure, so pillar 1. Emerge.
It's a pillar 1. Okay, so it's a pillar 1 project, but now you understand a little bit. Pillar 2 is mostly about consortia, big consortia, trying to address European industrial competitiveness. So usually I've been working a lot with Cluster 4 on digital industry and space. So there are specific topics, and you build a consortia around them, and you tackle those problems. The European Innovation Council is in pillar 3. So it's really about innovation, and it's really about deep tech. I'm not going to show much more about this Horizon Europe map, but I think it's important that you understand that there are many other ways of funding your research or funding your innovation. But in our case, the focus is really deep tech innovation. So this is how we see the entrepreneurial journey at the European Innovation Council. So we have like 3 instruments going from research all the way to business. The 3 instruments are called the lowest TRL one is called Pathfinder. Pathfinder tries to fund projects that are at TRL 1, let's say, starting at TRL 1, going all the way to 3, 4, meaning from an idea, bringing it to the proof of concept. And also the business readiness in that case will be really low. So you don't really know where your business will bring you, but you already need to think of what the application could be, but this is a Pathfinder, so we are not asking you to have your product super clear. Then we have this other instrument, which is called transition. So transition goes from TRL 3.4 to TRL 5.6. And here we are asking you to start already understanding what your stakeholders will be, to have a minimum viable product, proof of concept of what you have done, tested in real environment or close to real environment. So we are funding this kind of projects. Usually it's a 2-year project, quite quick, that you understand if you are well positioned, you are really understanding the need of the market. And we bring you to this TRL 6 in preparation of the next instrument, which is called Accelerator, which is really to fund the startups. So the Accelerator, we give grants to the startups, and we also give equity part. Equity meaning we invest in the startups that we have. So it's usually TRL 6 up to TRL even 9. So really bringing everything to the commercialization. And those are the instruments that have been conceived in the European Innovation Council to really make this journey from very low TRLs, very low BRL, business readiness levels, all the way to the business. But not only we give fund, we also try to have other instruments to really support this success in the entrepreneurial journey. So the main services are called the business acceleration services. We have workshops for entrepreneurs, a lot of mentoring, many coaches. We also try to help you in creating these ecosystems. So bringing you in front of investors, bringing you in front of end users. So it's not just about giving you the funding, but also helping you in building your network to bring whatever innovation you have to the market. And also this, the role of the program manager. I am the program manager for responsible electronics. So this role is also part of this instrument to support the success of the entrepreneurial journey. So we also help in building this ecosystem to our projects. And another important topic another important role for us is this challenge portfolios. So we are the ones putting the challenges. The challenges mean that we are somehow steering some of the policies and bringing some specificities to that we want projects to tackle specific problems. One of the challenges was this responsible electronic challenge last year, which has been super successful, and now we hope to start the projects at the beginning of just after summer, hopefully. So this is some of the challenges that we had in the 2020. We have for this year, the 2024. So in my case, I have this challenge for nanoelectronics for energy efficient smart edge devices. This is the challenge on responsible electronics for this year on Pathfinder. But there are many other challenges because I am not on my own as program manager. We are, at this moment, we are 11 on different thematic areas. So some people are working in health, other people in food, architecture. I work together with my colleague Samira. We work in the electronics field. But also 3 people are working in the energy sector, for example, and Stella is working in space. So each of us try to tackle these thematic areas. And we have these priorities, let's say. So on one side, we identify the challenges. Based on that, we select the portfolios of projects. So we really want to build a community around specific thematics. Responsible electronics is mine. And once we have these projects, we do this, what they call this proactive management of the project. So we really try to do things together with the portfolio. It can be helping them in transition into the innovation, but it could also be regulatory things. In the case of a responsible electronics, there was a lot of focus on the metrics and life cycle analysis, for example, tools. So there was a lot of effort put on that, and I hope once the portfolio is built, we can share that kind of things. Of course, also sharing technologies that are of interest among the projects. Usually we have 8, 9 projects in each portfolio, and this is what we want to build around it, okay? So this was for what has to do with the EIC. Afterwards, I will give some examples of some projects where we are. But now I wanted to go back to the theory of innovation management so that we understand where we are at this point.
May I ask something here?
Yes.
So I understand that within the same challenge, you're going to have interaction between the different funded projects, so to build this portfolio, but do you expect also interaction between projects of different challenges, so to have a broader coupling between the different challenges, or they are isolated?
Well, they are not completely isolated. If there are challenges that can make sense to put them together, we put them together. We are doing that already with projects that are in the open calls. So people that don't address a challenge but are in the open, I will show some examples of that also. That we think that can, by working together, there are synergies, and that's very important. So we're working specifically with the open projects. Yes.
Thank you.
So innovation in general, this is a little bit of theory. I'm sorry, maybe it's going to be boring, but I think it was important again to understand what the important pillars are in the innovation of management. So of course, we already talked about the customer, we talked about the market. So customer insight is super important. There are many ways to understand the customer insights. I will give some examples of how we are doing it. Not an exhaustive list of things that have to be done. So customer insights is super important. Very important also is the protection of the IP. I have a couple of slides on that. I really want to make sure that we understand that IP, especially in deep tech, is super important to have. And I hope I can convince you that. Also understanding the competition, so the patent landscape, if you have freedom to operate, if there are other products that can really block your developments, that's also very important. And that's important also from the beginning of the research. It's not something that you have to do at the end. I will also show you with some examples, this stakeholder mapping, understanding your value chain. So that's for your value proposition and for understanding where you could reach the market. It's super important. something that sometimes people don't talk about it is about the team. So team is super relevant for the success of especially the startups, but in any case, also in the research and on the journey. And finally, what's my unique selling point? So identify the opportunities and the value. Your tech to market fit is super important. I will start with the IP and the competition. So IP management, as I said, I really want to stop a little bit here because I think at research level, not everybody sees the value of patenting. I know it's very long process, it's expensive, but IP helps you a lot in the journey to innovation. So at the first place, it gives you the right, but not the obligation to create new products and services that others will not be able to do if you are the first one patenting that. So they have a value on themselves. Once you have a company and you create your startup, in the valuation of your company, patents have a lot of value, and this is super important to make sure that you understand. And in that sense, it helps in the negotiation with the investors, with other stakeholders. So it puts you in a position of power. It really does. And we see that venture capitalists and other investors see patents as really reducing both technological and competitive uncertainty, risks, and I really want to make sure that you understand that IP management is super important. So protecting what you are doing is super important. Maybe I can stop here and ask you if you know what types of protection are known. So for sure, patents is something that everybody has heard about it. I don't know if someone wants to jump in and mention other ways of protecting. Well, there are many ways of protecting. If nobody wants to try, I will give you the other solution. So other things that can be done, of course, is the trade secret. This is very used, for example, in materials. So usually you don't want to patent a materials development. Sometimes yes, it depends, but because once you put it on the patent, maybe many people can just copy it, and it's very difficult afterwards to say that they are copying your process and the way you're doing your material. So it's not always good to patent some of the things, and sometimes a trade secret is also very important. Okay, it's also very relevant, and it can also be a good way to go. Konstantinos, do you want to say something?
Yeah, there are some comments in the chat. So
okay.
Someone about industrial secret and MOUs.
Okay, the memorandum of understanding. So what's the question exactly?
No, I think they're responding to your.
Okay, very good. Okay, yeah. So yeah, industrial design, of course, is something very relevant. Trademarks, copyright. The memorandum of understanding is mostly when you want to start licensing or you want to have a contract and you want to transfer it. But yeah, it's also a good way to understand how I do my protection. I have another slide talking a little bit about these transactions with the IP. So yeah, this is what I wanted to show you. This is the patenting strategy of someone who has been super exemplary. And it's always shown as someone that could be an example for many people. So this person has more than 170,000 citations, but at the same time, he has been able to license his patents, 360 patents, to more than 300 companies. So this is very important. And the way he understands this is that you need to patent early. Usually in the States, they say patent broadly. This is not always the case in Europe, but this you will use some of patent attorneys to help you in this. But sometimes using these provisional patents and somehow helps you in blocking if you really think that you have something super relevant. And so broad blocking relevant patents are important. And then once you go to your licensing, it's very important that you are able to carve a little bit up and look into the field of use maybe. And so you license only based on the field of use. You license to other people based on the geography. You can also limit the period of time. So this is very relevant so that you don't get stuck with someone that maybe doesn't want to really exploit your patent, but is just looking for your license to do something else. So the part on the licensing is another relevant part. And I didn't mention much about the strategic timing, but timing is very important, especially if you go for a startup funding. So I'm not going to go through too much through it because I don't want to focus on a startup, but the timing is very important. Okay. So now I'll go to the competition. So understanding who your competition is really relevant again. It's maybe, I'm not going to say if it's the second most important part, it's very relevant. So really doing this patent landscaping, from the beginning, understanding that you have the freedom to operate. So this freedom to operate analysis are important because maybe you are investigated in something that will never reach the market because it's already blocked by a patent. So doing this patent landscaping analysis of publications from the beginning is super important. And then also this analysis of the products in the market and analysis of other disruptive ideas that could affect the need of your innovation. The example, very common example, is the one of the picture, Canon and Kodak, that at some point they completely lost the track on this, that they didn't even realize that where the market was going. So why would you invest in, I don't know, in specific ways of doing this lithography if nobody's going to use it because now there's solid state solutions for this. So it's not really only looking at products similar to yours, but also what the complete ecosystem of where your product will be entering, how does it look like? And all those moments are super important, especially if you're going to deep tech innovation, that things go so fast that you really need to understand where they are going. Okay. So coming back to my slide, I want to focus now on the team. Team is also very relevant, especially when you're trying to build something. So innovation is really a team sport. This is something that everybody says. So together, everyone achieves more. It's really multidisciplinary. Usually when we have all these deep tech innovations, it's not just about electronics. It's about electronics. Sometimes you mix it with biology, there's materials, there's people working on software. So building a team that covers all your disciplines is also very important. And I think it's also very important to mention that failures in innovation shouldn't be looked at them as I shouldn't try again. The opposite, this is how this works in the States. So people that have failed in their startups, usually they get more money than the ones that, that have never failed. So failure, it's okay to fail when you want to bring your innovation to the market. Okay? So really you need to build a team. You need to have this team spirit. You need to have inspiration. Your goals need to be super clear. The different competencies, disciplines should be there. You need support and you need a lot of motivation in this journey. We know that especially for deep tech, it's super long, but it's very rewarding. So I hope that you are interested in that. And we are seeing very nice teams now in our projects, and it's great to see them working together. So maybe I can ask a little bit, who would you, if you had to fund a startup, what are the first profiles that you would like to have in your company? If you just need to have, let's say, 4 profiles, which are the profiles that you would like to have? So
any comment from the audience?
Yes.
You can speak directly, or you can write in the chat.
We always tend to think that because it's deep tech and if it's a lot of technology, we also always tend to think that we need all the technology. And that's very relevant, but we see that investors are really looking for business developers. They are looking for other things like people that don't not only understand the technology, but also are able to go to the market. So I just put a couple of examples of theories on how would you build your management team. So you are the CEO, maybe you are very technological, then try to gather with you people that are more in the business development. So the CTO is very clear always. So So it says that 9 times out of 10, the CTO is the first to hires. So, and it's very relevant, of course it is, especially in deep tech. But also the marketing / sales people are important. And at some point, very early in your startup, you will need a financial officer, because you will deal with many things related to finances, and this is usually for a researcher very boring. So we always recommend that from the beginning you have your CTOs, of course, but you also have a CFO and usually a marketing, a sales, a business developer. So those are the important roles in your future journey to innovation. So don't think that you have the technology and all is done. No, you need relevant people that are able to talk to the market, are able to understand the other stakeholders, and are really willing to do that, and they like that, because sometimes researchers don't like that, and that's okay also. You don't need to do everything. Okay.
But okay, if I can comment, in reality, when you build a small an SME, you don't have the capacity to hire many people at the beginning. So you start the co-founders, let's say it's 1 or 2 people, and then you gradually build a company. But yes, I agree. This is the best plan to build a company, but maybe not at the very beginning.
Well, it depends on the technology level of your company. It depends on where you are. Those are general ideas, but as soon as you can, you need to have a business developer, because you really need to understand what the market is about. You need to have someone that is able to talk to end users, is able to talk to the supply chain, to the value chain, and sometimes that's not a researcher. Yeah. But it depends a little bit where you are. Right? It doesn't mean that everybody's at the end and they need to start selling. But I want to make sure that you understand that the business developer is super important from the very beginning.
Okay,
and now I will go to the very important part of doing this analysis of what's your unique selling point. So identifying your opportunities, the value that you are giving to the market, and really finding your tech market fit. So there are many tools. I like this one. I like very much this business model canvas. I'm not sure if at some point you will have a specific talk about business development, but I like it very much, because it's very visual. So you just need to feel this, and this allows you to really think about everything that you need to understand what's your value proposition, who are your customers, how you deal with that. Usually this is very common. I'm not reinventing the wheel. So usually you start with the value proposition. You have your value proposition. I have developed the best sensor to detect whatever in water. And so you start with that. You just need to put a sentence on that. So I have the most precise and most sensitive sensor for blah, blah, blah. And that's your value proposition, one sentence. And then you start analyzing. Some people start from the customer, but usually I like to start with the value proposition. Then you go to your customer segments and you say, I have this sensor for water. So who should I sell it to? Should I sell it to whoever is responsible of the water in the city, in my city? Should I sell it to, who should I sell it? To people that are doing these examinations of the water contamination? Who should I sell it? So who's your customer? Who are you going to sell your product? And once you know who you are going to sell your product, then suddenly you realize that you thought about a portable system, but you are going to sell it to someone that doesn't want a portable system, or the opposite. I have a big thing that needs to bring it to the analysis company, and what I have developed is something that is portable. So I put portable in my value proposition again, and I say, I have this that is super sensitive and it's portable. And then when I say that it's portable, that means that maybe my customer is someone that is going to go to the field and is going to measure in the field. So maybe it's not the same town hall, whatever company. Okay, so this is to help you bring in back and forth your value proposition and really understand it. Then you go to the channels. How will you distribute? Who is? This is not so important, but of course, the two important pieces are value proposition, customer segment. And then you also can go to who are your partnerships. So am I going to fabricate it, or I'm going to do it in partnership with someone? Should I subcontract part of my process? My software will be developed by someone else. How will I manage this? And all this will give me what are the key activities, which are the key resources. And that way, it's very visual. And this is very easy then to share with the rest of the team, to keep on analyzing where you are. So this is something that I really recommend that you can do from the beginning. And then when you are a little bit more advanced, then you can go to the revenue streams. You can go to your cost structures and see if your revenue streams are matching your cost structure. So really your costs are not higher than the expected price and how many pieces you're going to sell. So I really recommend that once you do that, when we have like longer schools, we usually try to do this kind of exercise with the students, and I think it's very relevant that you think about your idea in these terms and see how you can you manage to put everything together. I see that I'm spending a lot of time with this part. So
if I may interrupt, there are some questions in the chat for me. So Hasner is asking, what is the best position for an inventor in her company, to be the CEO or to have other positions in the company?
Well, it depends a lot. This is an answer, very difficult one. So if you are a researcher and you are really into technology and that's what you like to do, become your CTO and bring a CEO that is able to pitch in front of the investor, that is able to do everything and is able to understand what the technology is about. That's my recommendation. If you are really into research, don't become the CEO, because you will have to do all these presentations. You will have to try to find money. You will have to go in front of all this, understanding your position in the customer segment. So I think CTO position for a researcher is the best one. But sometimes the CTO, the researcher, loves to do this business developer. We see, and that's exceptional and it's great. And usually those are the best companies, because that's someone that is really understanding the value of the technology and is also able to understand the market, and that's very good. So there's not just one answer.
Okay, there is another question from Maria. Besides having technological knowledge, what are the 3 skills that all the team must develop to achieve an innovative view? So, what are the most important skills that they should have on top of the technological knowledge?
Yeah, well, that's a very relevant question. And again, that's why I put this team building, because you can grow on these skills, but you always need the team. So skills like communication are super important. We see that every day that, as I said, you need to pitch in front of investors. You need to talk to so many people that communicating what your development is, what your value is super relevant. So communication is very important, especially if you want to have this business development role. And other very relevant skills have to do with organizations. There are so many things happening in a startup at the same time. So really problem solving and timekeeping, being able to manage your time is super relevant. So, but usually it's communication and skills in communicating are super relevant, and problem solving, because you will find many problems, and not only technological problems, also problems along the line of all your journey. So yeah, but it depends a little bit on the role. That's why we always say that team is important, so that you bring all the competencies to the team. Yeah.
Great, thank you.
Okay, so this is a wrap up a little bit of this innovation and how it has to be managed. So on top of the screen, you have this technology market matching. Very important. We also talked about this protection of the invention. So IP protection, IP management is important. The team is on the bottom of the slide again, and this is also the 3 basic pillars that everybody puts as very important. And then we have, if we go for the startup, you have all this strategic timing and venture capitalists that I did not go through, and I don't think it's the topic of today, but it's also very relevant. Okay. So now I want to bring it to our EIC, to the responsible electronics part. So I hope I can go a little bit faster now. So this is really the customer insight. So customer insights for responsible electronics. Do we have demand for that? So you really need to understand where the demand is. So I am bringing this article from EE Times. In my case, it's about semiconductors. So do startups have a place in the semiconductor supply chain? Well, yes, and sustainability is one of the things mentioned. So materials and processes are very much mentioned for these startups. So for novel innovations are really needed in the semiconductor supply chain, in materials, in disruptive manufacturing, but also in sustainability. So there are many things happening in sustainability, innovations to replace solvents, to replace acids, manufacturing processes, things related to the energy efficiency of the devices. So yes, we can already see that there's innovation needed in this responsible electronics field. There are other things related to generative AI, of course, to test and measurement. So sensors also are very welcome as innovations in this semiconductor supply chain. So another way of seeing the insights is understanding who is doing what. So I bring this slide. It's about SEMI Association. So SEMI is the largest association of semiconductors in the world, and they already created this sustainability initiative and a group, and they have this Startup for Sustainability program in place. It's going to be the 3rd year. This means that, yes, the big players are really asking for novelty, for innovations in this field. Some examples of the things that they're looking for is emissions technology, so mostly sensors, energy, water. I am showing the parts on the materials. So yes, they are looking for other ways of sourcing, mining materials for the semiconductor manufacturing, sustainable processing, storing or shipping of materials, including on-site production, recycling methodologies, green hydrogen, hydrogen recycling. This is what the semi-big players are asking for from these startups. So they really want the startups that could somehow bring them innovation in these fields, because they don't have it. And of course, they need to bring it from somewhere. So the insight, the customer insight, tells us that, yes, we are very well positioned as responsible electronics to find a place in innovation ecosystem. And now I wanted to bring some examples also of how can we map these stakeholders and understand the value chain. Again, I'm bringing the supply chain of the semiconductors. I know electronics is not only about semiconductors, but I think this is very relevant. And it's funny to see, because you can see Europe in the middle. We are not the best in the semiconductor supply chain. You can see that we are pretty good at the tools. We have ASML, but on the rest, we are not so good. We are also good at IP, but it's basically ARM in the UK. So we are not so good. We have all these things happening in China. I mean, most of the things happening in Taiwan if you go for a fabless company. And many things happening in USA, especially for the design and simulation tools, for example. So we are not strong at anything in Europe. We are just strong a little bit on tools. We have some things on materials. So are we the best position to take part in this supply chain? How can we have to think about all this, okay, when we find the innovation. So I'm bringing a couple of examples of our Pathfinder project, so really low TRL, so that we can somehow think together. And for example, this first project is about electronics based on proteins. So, well, they claim that there are so many proteins, conductive proteins, that they would like to use them for biosensors on one side, but also for other electronic fields. So this is about materials. This is very deep. How can they bring this to the market? Will they be selling the final protein cable, let's say? This is the kind of things that we try to make them think about when they are in the project. This is Pathfinder, as I said, so it's really low TRL. And out of what's coming out of this, where do they want to bring it? How can they bring this to the market? And this is very difficult in that case. So I'm showing another example, which is, I'm going to say a little bit easier. So it's this machine, this process called 5D nanoprinting project. They are developing this, not only the machine, but also the materials. So at the end of the day, they will have a system. So this, as you may imagine, this is maybe easier to bring it, especially in Europe, to the market, because they will have something which is completed, let's say, and we have tool makers around in Europe. We are strong in that, so that will not be so difficult for them. I'm not saying that they're going to be successful and the others not, but I just want to reflect together with you on the kind of things that you need to look at when you start your journey to innovation at really low TRF. And now I want to show a couple of examples of what we have at the accelerator projects, meaning really the startup is already funded and they are receiving money from us to grow into and to go into the market. So we have this Morphotonics project, for example. They are about pioneering large area nanoimprinting. So they really have a focus on optical devices, meta lenses, and things like that. And they have a clear machine that they want to sell the machine. So they have a clear message to the customers. And this is our machine. If you are doing this, this is the best solution for you. And I'm bringing also a couple of examples of more on materials. So one of them is this Nobula. They do this glass 3D printing, which is also very relevant for optics. And they are also, it's more niche, but they are finding their way also as a manufacturer of these processes of 3D printing glass. And the Comtech solution, they are manufacturing a material. So it's a novel passivation technology, also for the optoelectronic seal. And they will sell the material. They will not sell a process. They will not sell a system. They will sell the material. And they are doing very good also. So yeah, we can have a material and we can bring it to the market. So in Europe, examples. And this is another example more on the computing side. So those are Pathfinder projects in the neuromorphic computing. This is not a challenge, but this is, we have built kind of a portfolio, Konstantinos, to your question. So there's a kind of a portfolio of 9 projects from the European Innovation Council around neuromorphic computing. We are bringing them together and we are having this workshop in Braga in next month. And the key motivation is really to stimulate the discussion on how to bridge the gap of going from these scientific, super interesting technologies that Europe is very strong in, and how can we bring it to the market and to the new applications. So this is going to be a complete journey, complete day working on this.
These projects are open, Pathfinder open, or
those are Pathfinder open. Yes, exactly. Those are Pathfinder open projects. Okay, that's so we also try to build the communities around Pathfinder open projects if we feel that they can do something together, and this is very relevant. Okay. So other examples of accelerate, in this case, that was Pathfinder again. So they still need to think how to deal with that. And this is accelerator. So those are 2 examples. This is on the bottom, Light10Tech. They are doing these big displays. They claim that it's very energy efficient, big displays for buildings. And the other one is Wave. They are doing this holography. So you can imagine that for them, the business is, in the case of the display, who do I sell these big displays to? Well, I need to sell them to whoever wants to put it. So probably it's business, what they call B2C. So business to the customer already. Whereas the other one, who do I sell this nanopixel holography? Now they want to put them in the goggles and everything. So maybe I need to go to the Apple, to whoever is doing this goggle. So this is more B2B, what we call business to business. I'm just giving examples to make you think about the different ways to go on the innovation. But now I'm struggling a little bit with the time, so I'll go fast to the challenges. I think Konstantino already knows, but I wanted to show you that the process to identify a challenge is not just that we, as program manager, we say, I want to work on materials for responsible electronics. This goes through a whole inter-service consultations internally in the commission, and at the end of the day, it has to deal with a key positioning of strategic areas in EU. So it's a very long way of working for these challenges, but in my case, I had this challenge related to novel materials, reduction of critical raw materials. That was my challenge for last year. called Responsible Electronics. It had a little bit also on integration, assembly, packaging, so really interconnections for easy recyclability, reuse. This was a challenge. So it was called Responsible Electronics, and we wanted to contribute to the development of materials. So it was really about materials. We had 115 eligible projects, and we are now selecting among 8-9 projects approximately. So really low success rate. We hope that the projects will start at the end of this year, and we are really looking forward to this because we have very nice projects that are being selected. And then I have another challenge for this year that is related more to the lowering the energy consumption at device level. So designing new devices that could really work on the heat dissipation, in chip heat dissipation. And this is the topic that I was showing previously, called nanoelectronics for energy efficient smart edge devices. So the overall goal is to drastically reduce energy consumption in order to meet application specific needs of smart edge devices and circuits. So this is a challenge that the deadline is October the 16th, and we are looking for very breakthrough ideas on how to deal with that. If you want, you can go to our program. And finally, and that I just have 2 slides, so at least I give 5 minutes for question and answer. So future outlook. So I hope I have really made you see that sustainability is in the electronics roadmap. If you didn't realize, there's even a white paper from IRDS. IRDS is the International Roadmap for Devices and Systems that is really tackling this. So this is on the map. This is on the map of the associations. It's everywhere. I'm showing a couple of examples. That one from Apple, maybe you've seen it before. So the carbon footprint of a smartphone in the whole lifetime is very big, but 38% of it has to do with the integrated circuit, which is huge, okay? And also I'm showing this other slide on the greenhouse gas emissions from the IC chip manufacturing, which is expected to increase 8 times and be equivalent to the annual emissions of 87 million cars in 2040. So we need to do something. So we are really in this field that is now very relevant for Europe, and is really we need to do something and have an impact on all this. So I end with this optimistic panorama. Yes, there's a lot of room for innovation in the electronics value chain, and sustainability is there. So really, we want to see many things in that, and I think that's going to be really very successful. The supply chain is very complex, but there are lots of opportunities in Europe, and we are seeing that. And even if we think that when we see that map, that's going to be very difficult, there are many opportunities. I think projects like Emerge that I didn't mention it, but I had a point where I wanted to mention that prototyping for our startups and some of our research projects is very relevant. I see that maybe linking to Emerge can be also very interesting. And my last comment is that the EAC is here to support all researchers that want to become entrepreneurs, and all entrepreneurs with the deep tech solutions willing to make an impact in Europe. So with that, I'm finished. Sorry if I took a little bit more time than expected, but I hope I kept you awake and interested on what I wanted to tell you. Maybe we have 5 minutes now for questions.
Thank you very much for this very nice and impressive presentation. Just regarding your comment about Emerge, we are open also to academia and also SMEs and companies. So we have users from companies, so we are open to new submissions, new proposals from your network of companies. So besides, we have also a new infrastructure, new research infrastructure, InfraChip, that actually is emerging of Emerge and Ascent Plus. Ascent Plus is an infrastructure for conventional silicon microelectronics.
I know it, yeah.
So we have many options to host this kind of SMEs.
Yeah,
great.
Very good. If you could send me the information, I would be glad to share it with some of our.
Yes, InfraChip started 3 months ago, so it's a very new research infrastructure. Just a comment from the question from the audience. Tam is asking, so since most of us are coming from research point of view, do you think placing IPs on your work is contrary to publishing in a journal? Can they be compatible?
Of course, they're compatible. You just, I didn't have the slide on first protect and then publish. Yeah, so yeah, of course, you need to publish, but first protect whatever you have. Once you have your patent submitted, you can publish everything, but you will already have your priority once you put you submit your patent. So yes, of course, publishing is very relevant for the community, for building the community. I didn't stop, but that guy that I showed from Cambridge, that is like the guru in innovation. He has, I think I mentioned many citations, and he has many publications, but he always says, first I protect and then I publish.
Okay, thanks. Any other question from the audience? You can speak or you can write down in the chat. Also, we have 2 minutes before moving to the next session. In the meantime, I have a question. Someone wants to speak or not?
No, I think it was me that I was trying to.
Sorry. So I have a question about the UK and especially UK SMEs. So about what is the, I mean, after a UK Brexit event,
yes,
is let's say, is a good, let's say, pathway to include UK partners in our projects and especially companies about conflict between EU IPs and UK IPs?
Well, that keeps on changing, but it's okay. Yeah, they're part of our programs.
Associate members.
I don't know now where they stand in terms of putting the money. I think they're putting the money now in the same bucket. So
associate members, but I'm asking about the IPs that will be
that's okay. That's okay for us. Is Europe? I mean, no, that's okay. That's perfectly well. There are some specificities. Maybe if you go with China, with what do they call not so friendly partners, but that's okay. No,
UK
okay. Of course, is part of our program.
I think. Thank you. Natalie wants to speak. I don't know if he raised her hand.
Yeah, I want to speak. For the acceleration program, do you think that it's a must to have a pilot plant or pilot scale first for the application? Because we are now in a lab scale and then we have a material, but yeah, we want to apply to the accelerator program.
Well, if you want, you can put, send me a message and we can check exactly where you are, because it's not mandatory. You can be a TRL5, meaning that you have already tested, but it's usually good that at least you have tested with someone from the outside has tested it. I'm not sure if this means pilot or you are talking about a pilot plant in terms of processes, but send me a message. No problem. I think Konstantinos has my email. I'm here for that, so I can help you on that.
Okay, thank you, Isabel. And another question, if it's possible.
Very briefly, because we have to move to the next speaker.
Oh,
yes. Last question.
Okay. I will. No, I will just text you.
Okay, so it's already 12 o'clock, so I think we have to move to the next speaker. So thank you very much, Dr. Obieta, for your participation.
No, thank you very much. Glad to share the slides, and you can give my email to.
Yeah, of course.
Thank you very much. Bye-bye.
Bye-bye. So with this, I would like to thank already he's with us, Dr. Libu Manjakkal. So am I pronounced this correctly? Manjakkal?
Yes, you're correct.
Great, thanks. So let me present the speaker. So we're very happy that we have together Dr. Manjakkal. His webinar will be on printed electrodes and sustainable electronics in general. He was about Dr. Manjakkal. He received a bachelor in 2006 and a master in 2008 in physics from Calicut University in India. Then he was with CMED in India, and in 2012, for a short period, he worked at Uninova in Portugal, in Lisbon. In 2012, he received the Marie Curie Fellowship to complete his PhD. in electronic engineering from the Institute of Electron Technology in Poland. Between 2016 and 2022, he was a postdoctoral fellow at the University of Glasgow in various roles, including Marie Curie experienced researcher, research assistant, research associate, and scientific project manager of a Marie Curie ITN project. Currently, he is a lecturer at the Edinburgh Napier University with a research focus on material synthesis, wearable energy storage, electrochemical sensors, supercapacitors, electrochromic energy storage, and energy autonomous sensing. He has co-authored more than 70 papers with 4,000 citations and an age index of 30. So with this, I would like to thank you for the acceptance to participate in our school, and the floor is yours. Thank you very much.
Thank you so much for the nice introduction, and thank you so much, Professor Luis Pereira, to introduce me this Emerge program. He's my good friend and good colleague. Okay, I'm going to share my screen. Before that, currently I am on my vacation. I'm in India, in my hometown in Kerala. If there is any problem I'm using my mobile phone to use my internet. Is there any issue in the internet interruption?
The sound is very good until now.
Okay. Thank you so much then. Okay.
Yeah, you can, yes.
Hope you can see my presentation.
Yes, perfect. Thank you.
Yeah. Okay. As I introduced, okay, today I'm going to discuss with you some of my research output and the current ongoing research in my team. Okay, I'm currently working at Edinburgh Napier University, where I am building my research team, because in my university we are mainly very strong in cybersecurity, system engineering, and computing science, and engineering application, many other fields. However, in experimental side, we have only few research group is focusing, and I am one of the researcher who focused mainly on the research side in Edinburgh Napier University, especially in Merkiston campus. Okay, so in my research team, I'm fully focusing on sustainable energy autonomous sensing system based on printed and coated electrodes for various sensors and energy storage device fabrication. Here is my team. Here is my main research group. Unfortunately, the website of my research team is not on the air. We will soon share that. We are mainly focusing on sustainable materials research and technology smart group, and where our major focus towards development or preparation of new materials, especially based on a metal oxide or polymer composite or a composite structured material. And based on that material, we prepare different type of electrodes, including potentiometric or a sensing for sensing and energy storage, like a printed, either in a screen printing or in a 3D printing method, or also in a spin or dip coating method. So we are developing different type of electrodes on flexible or non-flexible substrate, including PVC, PET, cellulose, paper, cloth, like different substrate we are utilizing for fabrication of different electrodes. And then based on those electrodes, we fabricated different type of sensors. It's wearable application or healthcare application. Today I will discuss about that, where we are going to implement these sensors and other type of electrodes. So this is one of the sensor we developed for glucose monitoring. And then those electrodes we also used for fabrication of different type of energy storage, especially flexible and stretchable based energy storage devices using sustainable materials. And then we integrated these sensors and energy storage devices to a wearable or other healthcare application or a pollution monitoring application. And for that purpose, we are collaborating with other academic or other institute. And also, you see, this all are, maybe you all know very well about the traditional type of sensors, energy storage devices, and everything. But in my research, I found some of the issues in the current sensors and energy storage devices. So our team are fully focusing towards clubbing all these together to develop a new bio-inspired sensing system based on ionotronics technology. So this is my major research focus in my team. Our 5 major research area, where we have 4 PhD students currently because in Napier now currently I'm in my second year of my job. So we have 4 PhD students and 4 research interns and 5 masters and 4 academic staff who supporting the research in my team now. See, as I mentioned initially, in my group, what we are focusing to develop our own material, and the full cycle means we prepare different type of materials, and then those materials we are used for fabrication of those materials we are used for the fabrication of different type of electrodes, and then we fabricated the energy storage devices and integrated those with the solar cell or any other energy generator, and then implemented this for a healthcare or environmental application. So when you consider this system, there are 2 major things we are focusing. One is sensing system. So in sensing system, as you can see that here, some of the sensors some of the sensors which I already developed in Poland. So one of the major area where I did my research work is on electrochemical pH sensor development, especially on a thick film substrate like some alumina substrate or any other substrate, where I developed my own sensitive material and also thick film reference electrode based on a silver chloride and reference electrode composite. See, in electrochemical pH sensing, one of the major problem is to fabricate a stable fully reference electrode, and this I overcome through developing a new silver chloride paste and integrated with a glass composite powder. See, you can see from here that this is a potentiometric pH sensor, and then another type of sensor we fabricated during that time is that interdigitated based sensor, where if reference electrode has some issues, or a impedance based measurement or a capacity based measurement, we used a IDE based pH sensor. This is one of the reference electrode. Yes, you can see from here that this is a commercial reference electrode and this is a thick film reference electrode, and also later I modified this into a flexible based reference electrode. Here you can see the silver chloride. Here is in a brown color you can see a silver layer is there, and then on the top of that KCl paste I prepared and then I printed by using a screen printing method. Another type of electrochemical sensor that time we developed is a gas sensors, especially for carbon dioxide or carbon monoxide or nitrogen monitoring. This is another work we involved. And then biosensors, for example, in electrochemical sensor, I implemented from the rigid to stretchable or a flexible one. As you can see from here, that is a stretchable pH sensor for a health monitoring, and then a textile based pH sensor, and then a chemiresistive pH sensor for a body fluid monitoring, and then in a body fluid analysis, different type of sensors we already fabricated in cloth or any other substrate. And then in addition to the electrochemical or biosensors, we also developed various type of physical sensors. I also involved in the various work on physical sensors, where pressure sensor, humidity sensor, temperature, and strain sensor. See, all these sensing system, when we consider any application like a healthcare or environmental or a agricultural field, you need not only a sensor. One of the major problem I found when I started my postdoctoral research in University of Glasgow, that I have a good experience on fabrication of sensor, but how to operate this sensor with a very less power. So I need my own energy storage devices. So during that time, I started to fabricate a flexible based energy storage device, and these sensors and energy storage devices I mainly implemented, for example, in healthcare, in wearables, and then food application or agricultural application, where in a precision agriculture you can monitor the pH of a solution or a pH of a soil, and or other humidity or other ionic properties in the soil. And then in the pollution monitoring, where this is one of the big project I involved as a scientific project manager in the Marie Curie ITN project. We have a different partners from the Europe, where we almost 15 PhD students are there, where we integrated. We developed the different type of sensors, pH, temperature, or a multi-sensor, and integrated with the underwater robots or a drone to monitor in a wide atmosphere or in a wide scale. Okay, so today my presentation mainly focusing on these three sections, where in a healthcare or in a food or agricultural, how our sensor or energy storage devices were implemented. So when you consider in a healthcare application, as you know that nowadays, especially after COVID or before that also, remote patient monitoring or a self-health management is one of the most important criteria, especially for a chronic disease management or a chronic different type of diseases or health fitness tracking, like many areas where personalized health system is most important. And for that, there is a huge technological focus on developing electronics in a different area in wound care or wearables. So you know that there is a demand for various type of sensors, various type of electronics, various type of energy storage devices to operate this these components. So considering this application, as you can see that when you consider a wearable application, there are different type of sensors. For example, sweat monitoring sensor. In a sweat, we are monitoring pH, glucose, salinity, iron, temperature, ethanol, and various other parameters. All these sensors require power. For example, a temperature sensor, one of the temperature sensor operating with a power of 30 microwatt. In addition to these sensors, there is analog to digital converter to operate these sensors, data management or a microcontroller or a Bluetooth BLE. All these electronic components also require powers. In addition to this sweat monitoring or a physical monitoring sensors, there are wearable physical sensors like heart monitoring sensor or a pressure sensitive sensor. So there are also a huge opportunity where you need either you need a less power operating sensor, or you need a very good power management system or energy management system. And then there is a human machine interaction, for example, in a prosthetic hand or a prosthesis or a software robotics application. So this I did a review on this in a few years back, and I found that there is a significant importance in terms of sensors and also in terms of energy to operate all these components. So considering this, my research is mainly focusing on electrochemical based devices, where the electrochemistry plays a crucial role in terms of fabricating sensor or in terms of monitoring the parameters. So in an electrochemical sensor, one of the most important, because we did a lot of other electrochemical sensors, due to lack of time, I'm not giving a detailed explanation about this. So when I consider in electrochemical sensor, especially in a wearable or a healthcare application, sweat is one of the most important parameter. One of my key work I published in a sweat-based energy storage device in few years back, where human sweat used as a electrolyte for an energy storage devices. So currently, you know that there are many research groups, especially in US and everything, Professor Joseph Wang and team. They developed many type of sensors for health monitoring, especially by using sweat, because in a sweat contain various chemicals, for example, ions, alcohol, or a different type of metals. So you can cross-link sweat parameter with the saliva or a glucose or any other body fluid. So there are different, for example, here you can see there are different type of sensors used for a human sweat monitoring. So considering the presence of ions or a glucose level or a pH level, one or the other parameters, where you can use human sweat as a major component in energy generator, where biofuel cell or energy storage, or there is a triboelectric energy generator where you can operate for a sensing application. And there are different type of supercapacitors or energy storage devices where using human set as a major component. Considering this, one of the work we recently published based on a human set monitoring is a glucose sensor. So in this work, what we did that day, we have a cloth-based substrate and also a glassy carbon-based substrate. And then we prepared our own composite based on a CU2O graphene. And then that CU2O graphene we prepared and then we printed on the top of a graphene-based electrode, where we initially fabricated a graphene-based electrode here by screen printing method. And then on the top of that, we developed our CU2O that you can see from here that day. And then instead of this is on textile, we demonstrated in this work like we collected the human set in an alkaline solution where it mixed it, and then it dropped on the top of the cloth substrate, and then like a portable sensor. And then you can see here that the performance of the sensor by using Cu2 as a sensitive electrode on the top of a glassy carbon. We monitored initially the cyclic voltammetry and other parameters analysis with various from under micromolar concentration to 1000 micromolar concentration. We vary the set glucose level, and then you can see from here that in a basic medium with a sensitivity of almost 1082.5 in a glassy carbon and 182.9 micromillimolar per centimeter square in a printed electrodes. So the main advantage of this type of sustainable sensor is that it's a carbon-based material and on the top of a cloth. Once you, like a portable application or a disposable application, once you monitor the sweat, you can throw it in the environment. So it's a biodegradable sensors we developed. And another type of sensors we recently developed, and some of the paper we undergoing that asset monitoring using a sodium or potassium ion using a supercapacitive sensing mechanism. Why I used this method is that, as you can see from here, that in a supercapacitor, there are different type of electrode. One is like a battery, one is a positive electrode or a negative electrode. You don't need to be fixed the one is positive or negative because it's a supercapacitor. You can consider any electrode as a positive or negative. But depending on the applied voltage, external voltage, and the electrolyte in the solution, if we applied a positive voltage here, the negative ions will attract on there. So what we did that day, on the top of a cloth, we doped coated with a P.PS as a conductive material, and then cellulose cloth we converted into a conductive cloth, and then with the various sodium variation in the human sweat or a set equivalent solution, we monitored the performance. As you can see from here, that by varying the sodium concentration in the solution, you can see the resistance is varying, the impedance is varying due to the conductivity variation of the solution, and it's like a straight line, and the impedance is like a Niki's plot. And this is due to the P.PS is a conductive polymer. When reacting with a sodium chloride solution, what happened is that there is an electrochemical double layer formation, and also due to the P.PS is a conjugated polymer, there is a redox reaction occurring. And by using this, the ions are storing on the top of the surface, and depending on the various concentration of the sodium chloride or the potassium chloride, the conductivity or the charge storage of the supercapacitor is varying. And with when we made a systematic analysis on the variation of the concentration, as you can see from here, that the sensitivity of the sensor, for example, the sodium chloride sensor is 2.5 to almost 2 millifarad per variation in the sodium. See, as you know that in different type of sodium chloride sensor, if it is a capacitive sensor, a normal capacitive sensor, the variation in a nanofarad or a microfarad range. But when it comes to the supercapacitive sensor, what happened is that the variation, we got a very high value. That means that the interference will be very low, and it's in a millifarad range. So these are some of the ions monitoring sensors we developed. In addition to this, we have also various type of pH sensors we developed for a sweat monitoring. I'm not giving a more detailed discussion on that. We can have a chat if you are interested in that work. During those studies, I noticed that in a wearable chemical constituent, for example, in the sensing application, there are different type of ions or a different type of analytes present in the human body fluid. The selectivity is one of the major issue. And the quality of the data or quality of the sensor data is another major problem. The lifetime of the sensor or a complex data analysis, the cost of the sensor, there are different parameters which influence on the sensing performances. So to monitor a more advanced sensors, you need another major component like applied electronics or physical electronics or electromagnetic components. So here, what I'm doing that I'm developing now sensor to overcome this issue of the selectivity or a sensitivity, or in a wearable application, sometimes we are not easy to manage with flexibles even in a plastic substrate also. So currently we are now trying to overcome this issue like a ionotronics method, where ionic gel as a major key component in the sensing performances. One of the key work we recently reported in Applied Physics Latest Journal is that a transparent electrochemical capacitor which is used as a capacitive sensor or a capacitive based energy storage, where we developed the sensor on the top of a PET ITO based substrate. Of course, we need to replace this with a PET or ITO. We're currently focusing on that work now. This is the preliminary work in our group we developed for an electronic based technology, where ionic gel, formation of an ionic gel to develop the sensing application, where you can see here that a transparent electrochemical capacitor we developed, and depending on different type of gel we compared with sodium chloride, potassium chloride, and lithium chloride based gel. And then this gel based electrode, we initially made the transmittance study, and it is almost 99% of transmittance we found. And this is a surface image of the IT electrode, where we got the contact angle with 72.6 degree. And then we did the electrochemical study of the sensor. As you can see from here, that the conductance of the ionic conductivity of the gel electrolyte, and then we measured the various impedance spectroscopic analysis of the devices, and then we found that lithium chloride based gel electrolyte shows very low impedance value and shows the better performance and a high capacitance due to the high ionic conductivity or a high or high ionic strength in the device. And then we measured the cyclic voltammetry, where is there any strong redox reaction. We didn't find any strong redox reaction, but there is a pseudo capacitance because of the ITO, the methyl oxide. And then we measured the capacitance of the device, and you can see from here that LICL found a very high capacitance. And then we analyze how much charge can be stored in this type of devices, and we found that the lithium chloride based devices varying with the scanning rate of the with scan rate. And then here you can see that in a very low scan rate, almost 4.5 millicoulomb per centimeter square in this one. And then we further calculate the charging discharging of such devices to implement this for a capacity type of sensors. And then you can see from here that in different current density how the transparent electrochemical capacitors varying, and then its energy density or a power density variation. And then we measured its optical property and also the mechanical property, as you can see from the variation of the band gap energy of these devices. And then see, such a transparent electrochemical capacitor, there is an in between a gel electrolyte is there. So we apply an external force on the top of this device, this electrode, and then when you apply an external force, what happened is that the gel electrolyte distribution is changing and the surface interaction will change. And based on that interaction, we found that there is a systematic variation in the force, with the force, the capacitance variation. And now currently what we are going to do, hello, everything okay?
There was a background noise. I mute the speaker again. Please continue.
Currently, what we are going to do that we found some issues of this work, where when we have a gel electrolyte with the transparent electrochemical capacitors, the leakage or the bending time, the leakage of the electrolyte, we need a very strong packaging. So we are now trying to overcome this issue with the solid electrolyte based ionic components, and we got a pretty good result. I'm not presenting that result here. And one of the good news that this work shortlisted as the one of the best journal work by applied physics letters in the last month, and we got a very good appreciation for this work. And now we are moving towards this for gel electrolyte with a surface modification by using various material. And for that, we are now trying to collaborate with CENIMAT in University of Lisbon with Professor Luis Pereira and his team. When I'm moving towards the next, where I'm implemented this sensor, as you can see that we have fabricated different type of sensor, and then we implemented this sensor for another application, where precision agriculture. As you can see that I know that I'm entirely moving towards my application from a healthcare into an agriculture, because where you know that in all these fields, in healthcare or in food or in a pollution monitoring, the sensors pattern is similar. For example, potentiometric sensor or an amperometric sensor. Only the parameter variation is that selectivity or the range of what range we are monitoring the solution. For example, in a pH monitoring in a different type of plant. For example, if you consider in the rosemary, the optimal protection for a rosemary, you need a pH in between 6 to 5, or in a cherry plant or in a different type of plants. It depends on the pH value of the soil. So this is one of the work one of my student did in last year. She was doing her master degree in that time. So based on my previous pH sensor, a potentiometric pH sensor, we developed a potentiometric pH sensor on an alumina substrate by using ruthenium oxide as a sensitive electrode. So here, what happened is that when you drop an electrolyte on the top of this solution or a soil on the top of yours, as you can see from here, that is a wet soil. What happened is that there is a bond created between these two. The ions are exchanging, and then a potential difference creating. So we developed the sensor and integrated the sensor with in a soil, and we monitored the soil property. But the major problem, this is one of the results we found, but the major problem what we observed that see, when you monitor in a precision agriculture application or in agricultural application, the major issue for a soil monitoring is that the water content property changes. For example, when there is a rain or when there is a different type of tap water you pour into that soil, the pH may change. In addition, with the buffer content in the soil, the pH will vary. So how can we monitor simultaneously the water which pouring into the especially in a home garden, the water which you drop on the top of the soil, and also the same time to monitor the soil pH. So what we did that we make an automatic system where we developed a pH sensor which inbuilt on the soil, where we dipped on the soil, and also the sensor is integrated on the a smart watering can where we integrate our sensor. So what happened is that if your soil pH, for example, if your soil pH is 5.5 and you need a pH of 6, and when you are pouring the water with a pH 6 or adjusting the pH value solution, you can monitor your pH value of the water you are pouring. And for that, you have an automated pump system here, and then a pH mixing solution, for example, an acidic solution or a basic solution. So depending on the pH required to pour on the soil, you can mix the water content and then pour in, and then you can monitor the pH, and also you can measure the humidity level of the soil. So this is one of the system we developed, and then we we analyze the pH in a different condition. For example, we also monitor the potentiometric performance of the sensor in the water or in the soil, as you can see from the result here. And also its simulation, we did one of the in collaborate with the Glasgow University. We measured from the sensitivity factor of the sensor, and then you can see here that there are different salts. For example, in a soil, there are different type of sodium chloride or magnesium chloride or a sodium like a potassium chloride, like different salts are there. We monitored the presence of salt, and to analyze the selectivity of the sensor, we got the best performance for the sensor, and also the pH value of watering solution with the stable performance of the pH value. This is small drift here, but it is negligible because of the large value here. And then one of the other applications what we did that we tested this not only for a soil monitoring, we also tested for a hydroponics application, where in a water living plants to monitor the pH. When I visited India in my hometown, I saw my brother have a lot of in a fish farming. He is using a lot of fish there, like a different colored fish. But the major problem he noticed that the water changes, the fish die, because the change in the pH value of the solution or any other parameter change in the water, it easily affect the water living animals or the fish or any other parameters. So I think such a sensor, such a potentiometric pH sensor have a very good implementation for such a hydroponics or a healthy fish monitoring application. And then here you can see some of the demonstration where we did. For example, in a soil monitoring, how we demonstrate the sensor. You can see here that this is a pH sensor here, and with the soil, and then as a continuous monitoring application, we are now going towards to replace this all electronics for a wireless application. And here you can see the sensor we covered with a small cloth, and then with a small setup we monitor the different pH value of the solution. And then another measurement, you can see here that this is a small setup we made in the laboratory, where we have a humidity sensor here, and we have a potentiometric pH sensor here, and then our sensor integrated on the watering can, and with a different pH value of the buffering solution there, and then we mixing the solution and dropping into the water, and then simultaneously you can monitor the pH value of the solution. In another work, as you can see from here, that in a hydroponics application where we have the water and the varying the pH of water, and which leads to change in the pH value of the solution. We use the different type of pH to down or up the water. So I found that the printed electrodes have that sensors have we fabricated using a printed electrodes. Those screen printed electrodes have a very good application for such as soil monitoring, especially if you need in a rigid substrate like alumina substrate, because the glass based sensors have an issue when you put in the soil, because it may be break or any other coating. So in this case, glass based the screen printed thick film based sensors have a very good application for such an implementation. In addition to this, what we did in another work on the pH sensor is that in collaborating with my previous PhD institute in Poland and one of the German underwater robotic company, Electrodes, we developed a pH sensor, okay, and then integrated with the temperature and the pressure monitoring sensor. This is a sensing probe, okay. So our aim was to monitor in a wide area of a river, okay, in a different depth level, for example, in the surface or in the middle or in the underwater, how the pH is varying. And for that purpose, glass-based pH sensing again have some issue. For example, if you want to integrate with a underwater vehicle or a compact-based system sensing probe. So we here integrated our sensing probe, sensitive electrode probe here on the underwater sensing probe, as you can see from here that, and then we monitor the water in a different type of water, and by compare this with the glass-based electrode and our fabricated sensor, as you can see that the sensor shows a very good performance and a comparable performance with the commercial based sensor. And then we monitor that underwater sensing probe. We monitor for example, in a river, there may be the salt level, the conductivity, water conductivity level may be vary. So what we did that we monitor the sensor in a different conductivity level of the water, and also we kept the sensor with a different conductivity, the drift variation, how much is the drift, and the selectivity issue of the water that sensing in a different field. And what we did that here, one of the major achievements for this work, that we found that a pure ruthenium based electrode have some issue, especially cost wise, and so we mixed the composite with the cobalt oxide. So we compare the performance of a different ruthenium oxide with the cobalt oxide based sensing electrode, and then we monitored the sensor hysteresis, because when you measure the pH sensing in a different type of solution, in a pH up or pH down, hysteresis is one of the most important parameter. And also you can see here that the sensor stability in a different time, for example, up to 25 hours, the stable performance of the sensor in a different pH value solution. And then we integrated this. We monitored in Germany, one of the German river, and also in a Poland lake, in different water, in different atmosphere. We monitor the sensor performance, as you can see from here that in the surface level and the depth level, in another depth level, or under 3 meter, how the sensing performances. And then the data we can store in the chip there, and then you can monitor in a mobile phone or in your computer. And then what we did that in a different depth level, we vary the pH value and the temperature value, and then we map that. So we found that in different, for example, almost 3 years, the sensing performance is almost stable. So if you want to map a river pH value or in a different depth level, the value of the pH or temperature, the underwater sensing probe by using a screen printed based sensors will be a very good alternative for the current expensive sensing. In addition to, as I mentioned in my initial slide, see, all these sensors required an energy as one of the key parameters. So what I did that to operate these sensors, to give a power for these sensors, I developed a different type of energy storage devices. As you can see from here that one of my major work in the wearable application, where what I did that see, when you focusing on a healthcare application, maybe our sensor will be ultra flexible, but the battery may be not flexible because it's maybe a rigid one. So currently there are different research groups focusing on a flexible battery. The problem of a flexible battery is that the strong or acidic electrolyte involved in that battery. So that may create toxicity in our health or the skin itching. So what I found that during my sensing study, in a sweat contain different sodium chloride or a potassium chloride. That means there is a positive or negative ions. Why not we can use sodium chloride as an electrolyte in the textile based electrode? So I converted the textile into a conductive textile, and then when I did in Glasgow University, what I did that we run in the one of the ground, and when we sweat, the sweat generate, and that sweat directly when contact with the cloth, the conductive electrode, the conductive polymer coating with that sweat, and when you apply a small solar cell, as a demonstration application, when you apply a small power to the cloth, what happened is that the charge storing on that cloth and it act as a supercapacitor. And that stored energy we used to operate the salinity monitoring sensors, because you need a very low voltage operating sensor there. And in another work, what I did that in previously, these all are my previous work where I did the integrated solar cell with a graphene foam based supercapacitor and a pH sensor. In this work, what I done that I used a 3D structured graphene foam to develop an energy storage. But the problem I found in this work, this one of the best work in the UK university. We got a best research award also. But the problem I found that graphene is a that store very small amount of energy in a microwatt or in a range when you fully fabricated the device. So to overcome that, in another work, what I did here that I prepared my own composite and new structured by printed electrodes, a graphene polyurethane composite, and which can operate in a 2.5 volt and which can operate in a different type of electronics component like sensors, actuators, and everything. And then currently, because in this case again I found that I'm using sodium chloride or phosphoric acid as an electrolyte, so I need to overcome. And then there is another issue of a flexible substrate where I'm using plastic based or a polymer based substrate. Now what I'm currently using that we have fabricated a paper based energy storage, for example on a cellulose based cloth. This is a packaging material there, again a cellulose cloth, a cellulose a paper, and then by blending a different type of composite, we developed a ultra flexible paper based energy storage to operate. In another work, I also demonstrated a natural fiber based where we can convert the fiber like a jute fiber into an energy storage device fabrication. And all this energy storage, or this device level fabrication, active electrode, the printed, either we use graphene or a graphite polyurethane or a metal oxide. So the printing of the material is one of the critical things. So in recent year, what we did that we investigated different type of polymers, how that performance on the energy storing. For example, a polymer based energy storage device, we use a conductive polymer like a polyaniline and a polythiophene. Okay, so I will give you a short overview of what are some of the energy storage devices. So this is one of the recent work, and I'm collaborated with the CENIMAT, Dr. Suman and Sumita, where we did an overview of what are the different type of natural fibers for a sustainable electronics to fabricate an energy storage devices. So this is one of the review paper we did, and on a natural fibers. And then previously, because I already developed a natural fiber based energy storage devices. So if you are interested in some of the work related to natural fiber converting, because you know that there are different type of fibers like bast or jute or hemp, we can easily convert that fiber into an energy storage or an electrode or an sensor. So as you can see from here that this is a natural fiber like a jute plant, and converted into fiber and coated with the conductive fibers, and then developed an electrodes for an energy storage device. And then you can see here that this jute fiber also converted into a sensor where humidity or a temperature sensor, so which you can integrated into a smart package like a cellulose bag or a cellulose cloth or a smart wearable textiles, where you can integrate this type of fiber based. Here there is a small fiber, you can see here this line, a fiber based energy storage is there, and also a sensor. So when I come back to this slide, I found that in the recent work, okay, we can easily modify the fiber like a natural fiber by using different type of composite like metal oxide, or a polymer, or a graphene, or a carbon composite to develop different type of energy storage devices. Currently, I'm collaborating with my another team in Ireland, where we are preparing new like a bilayer polymers, or a layered material, or a metal organic framework to convert these fibers into an energy storage devices. So some of the papers are now under review on in this area, where we got a pretty good result on that application. So as I mentioned that I'm describing one of the small work in a recent we published on a conductive polymer. What we did that we have a PVC or a graphene based PVC substrate in which a graphite film we coated, and then by spin coating method, what we did that here you can see the graphite and then covered with the polythiophene, and also another conductive polymer we used a polyaniline, because we need to compare in a sustainable electrode fabrication which conductive polymers shows the better performance for an electrochemical energy storage device fabrication or a capacitive sensor, capacitive like energy storage device. As you can see from here that when we compared the polyaniline based supercapacitor or a polythiophene with a different type of electrolyte, we found that polyaniline with an H3PO4 got a better performance, like a low impedance, and which means that which can store very high energy, and the impedance value variation you can see from here that, and then also the board impedance plot you can see that the variation of the performance. Here you can see the polyaniline based supercapacitor shows a capacitance almost 4 millifarad, and then as compared with the polythiophene. And then we compared the cyclic voltammetric analysis for both devices in different scan rate, and you can see here there is a pseudo capacitance reaction because of the polymer, conductive polymer. There is a electrochemical double layer formation in addition with a pseudo capacitive reaction due to the conjugated polymers. So in effectively we compared in this work we compared polyaniline, polythiophene, and P.PSS, and among these we found that the P.PSS is one of the best. And then now what we are going to do that we are making a composite structures of the conductive polymer with a metal oxide, because the metal oxide what we found in one of the recent work that the resistance offer less performance for the energy storage device fabrication. But when you are making the conductive polymer composite for a printing technology, you can make easily a flexible substrate so for energy storage. So here you can see that the charging discharging cycle for the different conductive polymer, PAC or PTSC, and its efficiency, and you can see almost 90% of efficiency for a polymer based device. And as I mentioned that in current work, one of the work we recently demonstrated for a textile based or a fiber based energy storage, where you know that what we did that we fabricated the electrodes filter paper as a substrate, and then conductive as a silver conductive ink as a current collector. We know that this is not a good option, but we are now currently trying to investigate a very good alternative for a conductive current collector, because we need a very good current collector to get more ion storage, and like a manganese based electrode, and also carbon black with a single based metal electrode. So it's like an hybrid supercapacitor. One of the major important achievement of this work is that see in battery or in energy storage device fabrication, cell guard is like a polymer based separator, one of the best separator reported, but we found some issue with the cell guard based electrode in a flexible application, especially for the high impedance. So to overcome that, we made a cellulose based separator, a bilayer separator, by using cellulose nanofibers, and then we integrated that here, and now we are modifying that performance. And if you like to get more information about this sensor, maybe you can contact me after this meeting and we can have a chat about this work. See, as I mentioned, we developed now different type of sensors and different type of energy. These are all for a sustainable society, like a healthcare or an environmental or a smart building application. As I mentioned in my initial work, there is a anatonic based device transparent electrochemical capacitors. So during that device fabrication, along with the collaboration with Professor Luis Pereira, we noticed that, and Professor Jin Jos in Leeds University, we noticed that a further modification on this transparent electrochemical capacitor with a new material like either an electrochromic material or a sensitive material like a transparent electrochemical ionic based capacitors. You can monitor the pressure sensor, pressure or a humidity and also these electrochemical capacitors could be utilized as energy storage devices like a multifunctional device. In the future, for a sustainable society, for a sustainable environment, we need more smart building or a smart electronics. And now currently we are one of the recent review paper we investigate these parameters, and now we are what we are doing that we developed one of the device now, and it's under review now. And in addition to that, such an integrated system, for example, sensors or an electrochemical display, you can apply it for a wearable application like an energy autonomous sensing system. For that, you need a very low small power devices like sensors or a very good energy storage devices. And currently we are focusing towards these two fields where an ionic based electronics have a key player. And in finally, our group have a major strength in fabrication of preparation of different type of materials, different type of electrodes like a rigid electrode, printed thick film, thin film, and flexible electrodes. Different type of devices like actuators and energy based on this electrode, different type of electrodes sense devices we fabricated and implemented this for various applications. And some of the facilities, as I mentioned initially, I'm currently building my team and currently building my lab. So we have some of the facilities where you can prepare very good bimetallic or a metal organic framework based electrodes in a dual syringe pump spin coater, and also dip coater and under controlled atmosphere. And also we have a very good soft printable material like a 3D printer for making a soft and stretchable. One of my PhD students now focusing towards to fabricate a soft based energy storage or a soft electronics application, where we have a good facilities now in my laboratory. And a small screen printer, we are now focusing towards to implement a new screen printers, and also various electrochemical workstation and various other measurement unit. And of course, my team, my students, very good support for all the research work, and I acknowledge their contribution. And these are some of the funding agency, and I am one of the editor of the journal Results in Engineering. So you are all warm welcome to submit your paper in next time in our journal. Thank you so much for your patience.
Thank you very much for this very exciting presentation. So we have covered many fields and different applications. It's very nice to see this. So now we have time for some questions. Let me check the chat. So Manas is asking, he's thanking you for this enlightening presentation. I'm interested in understanding why copper oxide thin films are preferred over other metal oxides in healthcare sweat sensor applications.
Yeah, thank you so much, Manas, for this wonderful question. So one of the major problems, one of the major advantage of CU2O, we found that it is a very selective material, especially for sweat monitoring. As you can see, there are different type of glucose sensors or also sweat parameters monitoring we found. In metal oxide based sensors, one of the major issue we noticed, for example, RU2 and everything, is the cost is one of the issue, and selectivity is another issue. And to overcome that, CU2O shows a mixed ionic and very good mixed ionic and electronic conductivity in our sensor fabrication. And we can further, our concept is minimize the material. For example, if you want to fabricate a sensor or an energy storage devices, if you are using different type of material for sensors, different type of materials for energy, that needs to be a very high investment for a material aspect. So CU2O will be utilized as a very good energy storing material also, because of its high specific capacity. And for that, you can easily modify the CU2O with the graphene or carbon based composite. In our recent work, we submitted what we did that CU2O mixed with a graphene or a conductive polymer. We developed a soft energy storage devices to integrate this with the CU2O based sensors.
Okay, thank you. Another question from Tammy.
Have you developed any of the sensors developed set analysis or utilization?
You can read.
Yes.
Great.
Yes. It is a good question. Of course, because what we did, I didn't show that presentation because I afraid about the time. What we did that day, we initially prepared the set equivalent solution. For any sensors or energy storage devices, we prepared a set equivalent solution, and then we monitored the performance evaluation. After that, either we collected the set or we integrated our human body. Like there is a video in my another slide. In a treadmill, we integrated a sensor in a treadmill, and then in that we integrated our sensor on a body or in a cloth, and then when we are doing exercise, the sweat generate and we can easily monitor the performance of this electrode. So we did in a real-time condition also, or the body evaluation situation also. Sir, in your presentation was very good. I am curious to know that did MOS play any role in the application like sensors? I think there are a lot of sensors, lot of materials, electrodes developed molybdenum sulfide MOS2 based electrode for various type of sensors. I didn't do any work on this. In a 2D material now, what we are doing that we are using metal organic framework. There are some of the 2D material we are developing in our laboratory. Of course, there are 3D structured or 2D structures are there. But that material now what we are going to use for an energy storage application. Of course, that 2D material have a very good strong application for a sensing and or other electronics application. But some of the problem in an electrochemical field, maybe stability or a hysteresis or a interference effect of other in a sensing application. So maybe you need to integrate this with other material or a composite material structure.
Okay, thank you very much. Is there any other question from the audience? You can speak or write down the question. Meantime, I have a question about selectivity in sensing. Yes. So this is very important. I understand that most of these devices are, the advantage is the low cost fabrication, and probably the short lifetime, but regarding the selectivity, I think it's quite difficult because most of them are multifunctional materials, so you can sense both moisture, maybe temperature and mechanical strain. So how you see this problem of developing sensors that can have selectivity?
See, this is one of the, because when during my last few years of sensing work on electrochemistry, one of the major question or a major problem we face with the selectivity, because as you mentioned that many of these material, as in the previous question also, many of these material are multifunctional. Maybe it may select one of the parameter. Only thing is that depending on the concentration of the solution or depending on the amount of the ions, the generated capacitance or ionic conductivity or the resistance or the impedance, the value may be different. So one of the method, data analysis method, what we can do that we can analyze the data in a different way, or there are different type of selective agents are using, like a polymer incorporating with the selective polymers or selective materials to implement for the sensor fabrication. What we are approaching that we are going to use a new selective material on the top of an ionic based component. So some of the work are now in a application are going on there to overcome the selectivity issue. So either the selective agent material or the data analysis method, you can implement the selectivity.
Okay, thank you very much. Is there any other question from the audience? Otherwise, I would like to thank you again for accepting the invitation in our school. Thank you very much. And also,
if anyone want to contact with our university or with our work, you're always welcome to chat with us.
Thank you very much. So with this, we close now the first part of today's session. So thank you. We have now a lunch break till 2 o'clock Central Time Zone. And afterwards, we have a webinar from Dr. Tahia. And now, before a few minutes, we sent you an email about the last webinar of the day. Unfortunately, there are some last-minute family issues with the speaker of the last webinar today. He provided a recorded video with similar focus of his talk. So we send you this link to his webinar, and also we upload this in the Moodle platform. So with this, I want to say after the last break, we have only one webinar, and the last one is cancelled. So see you everybody in almost 1 hour. 1 hour. Thank you very much.